All right, let's take a look and just take about 30 seconds for type 1. Just take 30 seconds. He said, well, you did that twice. You did that twice. I should be able to look at it and said, I think I know type 1. So right there? Okay. Now let's take a look at type 2. Look at type 2. Who wants to help me out? Tell me what's difference. What's the different about type 2 than type 1? Yes?
Not and always.
All right, and that's really the only difference, isn't it? So it's still binary, isn't it? And it's still a metal and a non-metal. It's ionic, and it just doesn't have an always metal. And what does that mean? It means there's only one way to make sodium chloride. See an always metal? But how many ways can you make iron chloride? And the answer is 2. Because, and I didn't do that, God did that. He said, some of those elements, I'm going to make them always form the same kind of ion. And some of them I'm going to be able to have them form different kinds of ions. It actually made the world a beautiful place by doing that. Many of the transition metals, if you're an artist, if you're an artist, you know that many of the colorful paints come because of those ions. Chromium yellow, cobalt blue, titanium white. There's some diamonds. Diamonds are clear, but if they have a little bit of titanium in it, those ions make it look pink. And they have other diamonds that are blue and other diamonds that are yellow. And so it's mainly those different kinds of metals that actually give color to many things as an ion. So take a look right here. And I forget who did this yesterday, who volunteered. You did that? Okay, so you said, you're the one that told me this was iron oxide? Okay, so this is iron oxide, this is iron oxide. But the problem is, that would be confusing, wouldn't it? Hey, go get me some iron oxide. Which one? Which one? So how did chemists fix that? How did they fix the problem?
Roman numerals.
Roman numerals. Now, here we go. That's one way they fixed it. Here's what they did. What is the charge of oxygen in a compound? And if your neck doesn't get sore looking at the periodic table, all right, what is the charge of oxygen in a compound? Everybody. -2. Okay. Now, all compounds have a net charge of how much? 0. So if this is -2, then what's the charge on the iron? And there, the charge, and Sean is an expert at this. The Roman numeral is the charge. Yes, he's an expert. And so he knows that. Now, look down here. This is a little trickier. Each oxygen is -2, but how many do I have? I have 3 of them. 3 times -2, -2, -2, -2, that's -6, isn't it? Well, then how many of these, I had 2 irons. If each of them are +3, 2 times +3 is +6, and so that'll work. So what's the charge on each iron? It's +3, and that fixed that problem, didn't it? It fixed the problem. All right, so I got to show you something new. Now, do you know before they figured out that the Roman numeral is a great way to fix this problem, they thought they had a way of fixing the problem, and it's like an older way of naming these things. And if this old naming system had gone away, I wouldn't even teach it to you. But they do. If you go to college, take chemistry, the teacher might say the word iron 2 oxide, or he might use another name. So let me show you. It'll take about 2 minutes, 3 minutes. How did they used to do it, and they still do, before using the Roman numeral to name them? And that's what this guy is right here. If you ever wonder what in the world, why is there a really scary looking thing there, right? And he is the big, icky monster. All right, now I'm going to use that to help teach this old system. The old system said this. He said iron comes in 2 and +3. Now I'm going to tell you that you don't have to worry about memorizing that, because here's the periodic table I'm going to give you on the quiz, and take a look at it. Do you see where it says iron comes in +2 and +3? So you don't have to memorize that, do you? I'm gonna tell it to you. Okay, so iron comes in 2 and 3. And then the old system used the Latin word for iron. What was the Latin word for iron? You said, wow, how much do I even take Latin? How'd you know that? Ferrum. How'd you know that? Wow, that's good. Anyway, I will tell you that too. You don't have to memorize that. I will tell you that too. Okay, everybody ready? Now, here comes the picture. Here comes the picture. Which one is bigger? Iron 2 or iron 3?
3.
All right, so he becomes the big, icky monster. Now, let me show you another name. What is another name for the iron 3? Here we go. Ready?
Pharaoh.
No, ferrum. I'm going to change it to what?
Pharaoh.
He's the big what?
Icky monster.
So he's ferric. That's the ferric ion. So this guy, this is called the ick and the us system. The ick and us. Ick and us. See that? So if you are the big icky monster, then you are the not so big ferrus. All right, now let me tell you how this works. Watch how this works. We're going to go up here, and there's another name. There's another name for iron 2 oxide. Okay, the old name is, what's another word for iron 2? No.
Oh.
Ferrous. Ferrous. You get that? Okay, now, so ferrous oxide. All right, now everybody stay right. Focus on me, okay? Iron 2 oxide is also known as, you're not the big icky guy, so you're ferrous oxide. And what would you call iron 3 oxide? He's the big icky. So I'll answer your question in just a minute. What is the other name for iron 3 oxide? No.
Ferric oxide.
Ferric oxide. Now, let's see if you're paying attention, all right? Hey, Hayden, can you close that door for me, please? All right. What is this? This is a really important discovery in chemistry. What is this right here?
That's the atom wheel.
No, you're close.
Oh. I don't know.
Anybody?
Atom pop.
No. The first answer you had, half the answer is right.
Wheel.
Yes.
Iron.
What is it?
Ferris wheel.
Ferris wheel. Okay. So anyway, I just want to see if you're paying attention. So this would be the Ferris wheel. Now, let's go to copper. And you don't have to remember that copper comes in +1 and +2, because I'm going to give you a periodic table that tells you copper comes in 1 and 2. You get that? I'm going to tell you that the Latin word for copper is cuprum. That's where we got the symbol Cu, isn't it? Where do we get the symbol Fe for iron? Ferrum. All right, now, let's go back up here. Now, look at here. Which one of these is the big, icky copper? Who's bigger, 2 or 1?
2.
So, the Latin word cuprum, what's another? Yes, the other name for the big, icky copper is cupric ion. And what about this guy? What's the not so big? Cuprous. Now, go back up here. Here we go. What is another name for copper 1 chloride? Cuprous, yes. What's the other name for the big copper 2 chloride? He's a big icky monster, right? What is it? Cupric chloride. Now, that's enough for right now. But if you were wondering, down here, lead, and the Latin word for lead is plumbum. No wonder Pb is the symbol for lead. Lead happens to come in 2 and 4. It happens to be 2 and 4. And who's the big, icky monster there?
4.
So, plume bic, plume bus. Okay, anyway, I just want to show it to you because if that system had gone away, I would be wasting your time to teach it. But it's still used today. All right, now I'm going to flip it over. We're going to do type 3. And if you'll stay with me, not only will we understand this today, I'm going to review type 3 tomorrow. And again, I will give you a periodic table, and it's got a bunch of stuff on it you're going to use, all right? Now, let's go to type 3. Now, what do you notice here? What do you notice here? The first thing you notice is what? Not binary. Now, I'm going to write one for you, okay? Here is a compound that is not type 1. It is not type 2. So take a look at this. Ready? How many elements are in this guy? 1, 2, 3. He can't be type 1 or 2, can he? I have some good news for you. If it has more than 2 elements, good news number 1, it contains a bunch of atoms that act like an ion. And the Latin word for many is poly. These are called polyatomic ions. They're ions that are made of many atoms. Now, I got some good news for you. Somebody else has already named that thing. Number 2, you will never change the name of a polyatomic ion. So I'm going to show you, this is going to sound like it's hard, but it's actually not bad. Now watch what I'll do here. If in your paper, I gave you a list of polyatomic ions right here. Everybody see that? So if you'll find that, you'll see the same sheet that I'm looking at. Everybody see that?
No.
It should be on the back. Look on the back. Now, what I'm going to do is the other class, the honors class, they had to memorize all those. I'm going to have to figure out which way I want to go with you guys. But I might have you memorize at least half of these, but we'll see. I'm going to see, all right? Anyway, excuse me. Now, what I want to do is I want you to look right here, and we know we're going to say sodium. And then whatever that, somebody else has already named that. All you do is find it. So see if you can find a thing called NO3. See if you can find it somewhere on there. Have you already found it? What's it called? Now, I didn't name it, did I? And you didn't either. But you can never change that name. So what are we going to put here? What? What? That's it? Yeah, that's it. Now, let's do another one. See if we can do this one. Look, how many elements are in this thing? 1.
C.
I'm sorry.
Die.
1, 2, 3 elements. Okay, it can't be type 1 or 2, can it? So the good news for you is I'm going to go look that up. So see if you can find. On the quiz, I'll give you these. I will give you all the polyatomic ions.
Oh, C.
Got it?
Sulfate.
It's called sulfate. Now, so what are you going to call this thing?
Magnesium sulfate.
Magnesium sulfate. And you said, whoa, that can't be. That's not possible. Can it be this easy? Now, watch the next one now. Watch the next one. And your brain has said, oh, I get it. I get what you're doing now. Here's another one. Ready? Let's go down here. Oops, you're not ready for that. Hang on just a minute.
Yes, I am.
Well, all right, there we go. Oh, dang it. Wait, I'm sorry. I apologize.
It's all right.
You're not quite ready for. Oh, I know. There we go. All right, ready? How many elements are in that compound?
3.
1, 2, 3. Is that right? Okay, now, what do you think?
Copper.
and then go find him.
Chlorate.
Yes. Now, did you leave a space? Leave a space. What? I didn't leave a space before. You know why you didn't leave a space before?
Because it was not.
What are these?
2 letters.
What are these?
9.
What are these and that's not?
Always the non-metal.
These are the always metals, and this is not an always metal. Remember, if you have one that's not an always metal, you have to do a little extra work, don't you? Would you look this up and tell me what charge does that group of atoms have? The whole group of atoms has a charge of what? Now look again. Look again. Look in the chart. Everybody see this guy? Everybody in this column has what charge? And that's what that little minus is. The whole thing has a -1 charge. Everybody see that? So this whole thing is -1. Now, what do you think the charge on the copper is? Remember, all compounds have a net charge of 0, and if chlorate is -1, then what's this guy going to be? Does everybody understand it's +1? Is that right? And help me one time, Sean. What are we going to do with that +1 there? You're the expert. What are we going to do with that +1?
The amount of charge.
And what's it going to become? A Roman numeral 1, isn't it? So it is easy, but if it's not an always metal, we have to do a little extra work to find out what's the charge on the metal. Yes? Do you see how type 1 and 2 kind of fit into the how to do type 3? All right. Now, what is the other name for copper 1 chlorate? Look right here. You'll have this available to you. Copper, cuprum, big icky, cupric, cuprous. Which one do we have?
Cupric. Cuprous.
Which one?
Cuprous.
You told me copper 1, didn't you? So is he the big icky copper? No. So he's cuprous. Okay, the other name for that is cuprous chlorate. Now notice you never change the name of a polyatomic ion. This is actually a little bit easier. The other ones I had to change the IDE, didn't I?
Yes.
Now, let's take a look at your homework sheet, and I'll help you do some homework questions. All right, let's do this right here. And let's do the first 2. Let's do the first 2, and see if you can name this one, and see if you can name this one, all right? Everybody working hard, right? That's what we do in class. We're going to work hard. First thing you notice is that it's not binary. It's got 3 elements in it. The good news, that means it contains a polyatomic ion. Good news. Somebody else has already named that polyatomic ion. Good news. You will never change the name of that polyatomic ion. Everybody got you got the first 2 done? That's pretty fast. That's really fast. All right, who wants to volunteer and tell me both of these? Who wants to do both of them? Who wants to do the first one? How about that? Oh, I thought you said you were done. Oh. Right. Anybody done? You want to try it?
Yeah.
All right, J3, real loud. And you know, I would say you would be right if copper would have been one of the always metals, but it's not. So you got to do a little extra work. Do you know the charge on sulfate? What did it say the charge on sulfate was?
-2.
That's a 2. -2, isn't it?
Yeah.
Now, if the whole thing has to be 0 and sulfate is -2, then what's the charge on copper? Yes. And Sean, what's he going to do with that 2 there? The charge on the metal becomes what? Yes. So see, you were right, except it wasn't an always metal. All right, J3, do the next one.
Copper sulfate.
Copper sulfate.
Copper sulfate.
Copper sulfate.
Copper sulfate.
Yeah, but what's this guy? It's kind of a funny one because it starts with K, but it's really potassium, isn't it? Potassium what? What about the Roman numeral? Look at me. No Roman numeral with an always metal. See, if it's an always metal, just say it. Just say the name. Just say it. Watch right here. Ready? Go down here. Ready? Watch. Find this guy here. What's this called? Carbonate. It's an always metal.
Potassium.
I don't have to do the extra work. Potassium carbonate. Look at this guy right here. See? Find that one. What's it called? It's an always metal. So say it. Sodium
Nitrate.
sulfate. That's this one. All right, let's go down here. Let's go to this one. Look at that. Look at that weird guy. Look at that weird guy. Acetate. That's a weird name. All right, ready? Hey, it's an always metal. No extra work. Potassium. Say it. Acetate. Whoa. Can't believe it. Sound like a chemistry person. How about this one down here? Look at this one. Go find that. Go find that guy. I saw you. I see you. And he's an always metal, isn't he? So just say it.
Magnesium hydroxide.
Yes. Yes. How about this guy? He's an always metal. You forgot that guy. Remember silver, zinc, aluminum, +1, +2, +3?
That's zinc.
And what's this guy called?
Zinc nitrate.
Yes. Next one is an always metal. We got
Sulfate.
magnesium,
Sulfate.
sulfate. That's another always metal.
Calcium.
Calcium?
Chlorine.
No chlorine in here.
Chlorine.
No chlorine in here.
It's carbonate.
Carbonate.
Carbon.
Look at this guy. That's an always metal.
Yeah. Potassium hydroxide.
Hydroxide. Ready? This one.
Calcium.
Calcium.
Oxide.
See? Now let me find one that's not an always metal. Let's go way over here to number 43. Let's go to 43. You're catching on to this, I can tell. Right, Gabe?
No.
We're catching on, aren't we?
No.
Now, Gabe, what would you call this one if it was an always metal?
Which one?
43.
Clobber, phosphate,
What do you call it? What do you call it? Oh.
copper, phosphate.
Oh, okay, copper. Okay, I thought you said clobber or it's something. Okay, copper phosphate. Now, Gabe, what we're going to do is, because copper is not an always metal, we have to do a little extra work. So, Gabe, help me out. What is the charge on this thing called phosphate?
2,
How much?
2, 4.
Wait. We're not going to roll the dice. Wait. What is the charge on phosphate? Look at it a little up here.
-2.
Okay, now look at me. This is where you got to really pay attention. Each, look at my hand. That's PO4. Ready? I hereby declare that whole fist is PO4. That whole fist is -3. But look at this little subscript down here. How many of these fists do you have?
3.
Okay, I love the enthusiasm, but we're going to get the right answer now. Ready? So there are 2 phosphates. Now, each phosphate's a -3, and you have 2 of them. What's 2 times -3? -6. Now, watch now. 3 times what equals +6, because it has to add up to 0, doesn't it? So, +2. Hit one more time. Hit me, Sean. That's copper 2. What are we going to do here?
But 2, numeral 2.
Yes. Got that? All right, let's try another one. Here's one, 44. Who wants to volunteer and said, I'll take a chance. I'll take a chance on that one. All right, Ben,
I.
do you know NI?
Yeah.
Nickel?
Yeah.
Okay, go ahead.
I was about to say that.
Okay.
Nickel hydroxide.
Okay, now, you would be absolutely correct if,
It ain't an always metal though.
no, it ain't. Now, what is the charge on hydroxide?
-1.
Ah, so what's the charge on nickel?
1.
+1. And?
Roman numeral 1.
Yes.
Or
I'll tell you, if you take this quiz, you're going to have Sean's voice. It's going to be
Hey, I got a
echoing.
question.
Yes.
So what would the name of that one be?
Okay, now, I love the extra questions. I love it. I'm going to answer, okay? Now, the Latin word is actually nickel, okay? Now, as a real person, if I were a chemist, that you say, hey, what would you call it in the ich and us system? And I'm a real person, so, okay, it must be nicklick. Now, as a real person, and you want to be a serious chemist, how many times do you want to say, nicklick, nicklick? And so I believe that most chemists will probably go with the Roman numeral on that one, and you'll never hear them say nicklick. Got it?
Ain't it one though?
Just like the planets. When I was growing up, one of the planets was called Uranus. And then I took 9th grade biology, and I found out that the end of an earthworm, where the poop comes out, is called the anus. And then I started seeing people on TV, they stopped saying the word Uranus because they would giggle. Uranus. Now, so they started saying Uranus. And then I thought, wait a minute, Uranus, I could laugh about that too. Wait, that's on, I forgot it's on recording. Oh, I'm all right.
Ain't
All
it
right.
one? It wouldn't be Nick.
Oh, okay, now, here, nickel's not one I use very often, but if I look over here, the periodic table tells me that the author of this paper, and I got this from a book, they made a mistake, but you don't have to worry about that. This periodic table tells me nickel only comes in 2 and 3, but they made nickel 1. Don't worry about that. Don't worry about it. Just, you don't have to worry about it. All right, now, here's what we're going to do now. I really think you're doing very well today. All right, now, do you know what I'm a little nervous about? Is I believe some of you, if I give you the formula and I give you all this information, I believe you're going to get very good at telling me the name. But what have I left out? What part of this have I left out? Is what happens when...
Oh, we can't see.
Uh-oh, okay, sorry. Find a sheet of the homework where they give you the name and you have to come up with a formula. All right, can you find that page? I gotta make sure I have the right one here. Do I have a blank one? Do I have a blank one? Do I have a blank one? Oops. Darn it. That's not blank. Darn it, that's not blank. Oh wait, I know. All right, here we go. All right. All right, here we go. Let's go with this top one here. This is a really, really weird one, okay? Now, I want to show you on the polyatomic ion chart. Do you notice that there's a whole lot of them that are -1 charged? See that? And there are not as many that are -2 charged. How many are -3 charged? Only a couple. And how many are +1 charged? Only one. Right there. You see it? So, when you write a compound, the thing that has a plus ion is written first. So what's the only polyatomic ion that might be written first? Ammonium. So here we go. Ammonium, that's not one of the elements, is it? You say, what the heck is that thing? All I have to do is look at my sheet, and I know ammonium is NH4, and what charge does ammonium have? +1. Now, what are you going to combine with it? Phosphate. That's a weird thing. Can you find it? What's phosphate? What's phosphate? It's PO4 and has a -3 charge. Now, this is something a little bit new, just a little bit. Is this a compound? Can this be a compound if this is +1 and that's -3? I thought all compounds had a net charge of what?
0.
This one's not a compound then. So how do I make it a compound?
Change the bottom numbers.
Say it again?
Change the bottom numbers.
Yes, but to which one? Do I need more pluses or more minuses? Okay. How many would like to have? Yes. See my fist? That's ammonium. I only have one ammonium. Don't say four. How many ammoniums do I have? Don't say four. How many ammoniums do you have? One. And it has a charge of +1, doesn't it? How many ammoniums would you like to have? What if I had 3 of them? +1, +1, +1. Wouldn't that balance out the -3? I need 3 what? Look at me. Ammoniums. You can't put a 3 here. That's 43, isn't it? What do I need? So on the quiz tomorrow, if I ask this question, what's the only time that you would use a parentheses to write a chemical formula? And you'd say, and I'll fill in the blank, when you need more than one, what's this called? Oh, any of these. We need more than one what? What are these called?
Polyatomic ion.
So when do you use parentheses in a formula? If you need more than one what?
Polyatomic ion.
Polyatomic ion. Okay, let's go again. Let's go down to this guy. Ready? Potassium. Look on the periodic table.
K.
And what charge is that?
1.
+1, right? Now, this is nitrate. So I have to look it up. And what's nitrate? Oh, there you are. What's nitrate? NO3. All right, NO3. But what's the charge on nitrate? Now watch. +1, -1. Hey, I think we're done. We're done here. See that? I would not put parentheses because I only need one of the nitrates. Next one. Ready? What are you going to put for magnesium?
Mg.
What's the charge on magnesium in a compound? Now, what about hydroxide? I'm going to look that up.
-3.
No. Where? What is it? What's that little symbol? What is it? Minus what? What are all these? Minus one. Okay. OH is -1, isn't it? Now, +2, -1? Nah, that's not going to work. What do you need then? 2, what are they called?
This.
2 what? 2 hydroxides. How do you say I need 2 hydroxides? You can't put a 2 here. That's 2 hydrogens. I need 2 of the whole thing. What are you going to do? Now look, if each hydroxide is -1 and you have 2 of them, what does that give you?
3.
If each hydroxide is -1, you have 2 of them, then what would that be?
Negative.
That'd be -2. What's -2 and +2? Ding, ding, ding. Compound. When's the only time you need a parentheses in a formula? When you need more than one polyatomic ion. All right, here we go. I want you to do this one. All right, when you get done, you look at your neighbor's paper and you said, I don't think you did that right. Or, all right, let's do it. All right, go. We're doing this right here. Gotta look it up. Here, I'll give you a hint. AL. There you go. Now, on the quiz, the second half of the period tomorrow, are you going to be able to have all these names? Yeah. Are we going to review the first 15 minutes? Yeah. All right, you done? Check your neighbor. Check both your neighbors. Ask Charlotte what she has. All right, I need a volunteer. Luke, can you help me?
What?
No,
No, yeah, he does.
Okay, will you listen carefully if I pick somebody else? Okay, Hayden. All right, ready? Hayden, you don't know this, but you looked it up, didn't you? What did you look up for sulfate? Everybody listen carefully, all right? To SO4, but what was the charge on the whole sulfate thing?
-2.
Now look on the periodic table, and aluminum is an always metal. But what charge does it always have in a compound? Yes. Now we have a problem here because look, 3 and 2, that's a problem. But I do know one thing. What's the smallest number that both 2 and 3 go into evenly?
6.
What times 3 is 6? If you gave me 2 of those, that'd be plus 6, wouldn't it? Now, how many sulfates would I need? What times 2 is 6? Now, you can't put a 3 here because that would be 43, wouldn't it? What do you really need? What do you really need 3 of? Look, you need 3 what? Say it. How many sulfates are right there right now? Right now. Don't say 4. Don't do it. How many sulfates are there? 1. How many you need?
1s.
No.
Three.
How many? I need 3, don't I?
Yeah.
And what's the only time you use parentheses? When you need more than 1?
Polyatomic
And you said you needed 3, didn't you? What's 3 times negative 2?
6.
Negative 6. And 2 times plus 3? Plus 6. What's plus 6 and minus 6?
0.
We have a compound. That's one of the hardest ones I can give you. That is one of the hardest ones I can give you. All right, we'll do one more. If you can get this right, you can go, okay? All right, ready? And I'll call on somebody. I'll call on somebody random. If they get it right, and go early, or a minute early, all right? Go. You can talk to your partner. You can even talk to your partner. We're doing this right here, number 10. Number 10. Gabe, come on. Oh, does everybody know lead is PB?
Yeah.
Okay.
Personal best. It's right there.
That's good. What's goat?
Summer Bob.
What's goat?
Uh,
What's goat?
greatest of all time.
Yeah.
Luke the goat.
Come on, we gotta go a little faster than this.
PB1.
All right, did everybody find chromate?
Yeah, it's CrO4.
What's the charge on chromate? What's the charge on chromate?
Why is the
Negative 2. Now, watch now. We forgot something, but Sean didn't forget. When Sean saw that Roman numeral 4, he knew to put what next to lead? Plus 4. He knew that. So lead 4 is lead 4. But this guy's minus 2. That's not going to work. How can I make a compound?
2 down there.
2 what? 2 leads? Or you want 2 chromates?
2 chromates. Put a parenthesis.
All right, bye. You did a good job today. Good job.